Okay, girls. So let's have a look at this section 12.6, where we will look at the gradient. What exactly is a gradient of a function, and also how to calculate the directional derivatives. How do we find the directional derivative of a function? So two things that we will have a look at. Okay. Are you hearing me? Yes? Are you okay? All right, great. So let me try and explain this idea of directional derivative, and then I will give you the rule how to calculate, how to find it. First, let's get an idea of what exactly is, what do we mean by this directional derivative. Suppose you have this function, x squared minus y squared. What is the domain of this function, by the way? What is the domain of this function, girl? Where is it defined? The whole of r squared, yeah? The whole of the plane, not just r squared, yani x in r, y in r, so it's defined everywhere on the plane. Suppose you want to find its value, for example, at the point 1, 2. What will be its value at the point 1, 2? The point 1, 2, which is somewhere here. What is the value of this function? Minus 3, very good. Okay. So its value is actually minus 3 here. At this point, the value of the function is minus 3. Now, suppose I want to know what's happening to this function as we move in this direction, given by the vector, say, 1, 1. What's going to happen to the function? As xy moves in this direction, what is happening to it? Is it increasing? Is it decreasing? Etc. in the direction of the vector 1, 1. I want to study this function only in the direction 1, 1. I want to know what's happening to this function as I move along this vector 1, 1 going like this. So I want to know, is it increasing, is it decreasing, and so on. Normally, when you want to know if a function is increasing, decreasing, what do you calculate? What thing that we usually try to find if we want to study a function and we want to know, how is it changing? Its derivative, exactly. So here, what I need to find is the derivative of the function f. I note this by df, but only in the vector, in the direction of this vector v. So I want to know, what is this derivative? Well, if this derivative, for example, is positive, that means our function is increasing in the direction of the vector v. If the derivative is negative, then it will be decreasing, and so on. So I need to find, this is what we call the basically directional derivative. It's a derivative in a certain direction, directional derivative. Now let me give you the rule for finding this directional derivative. There is a really nice, easy formula for finding the directional derivative of a function in the direction of a unit vector u. Then it's fx at AB multiplied by u1 plus fy at AB multiplied by u2. Okay, so that is the general idea. So let me give you then, let me have a look at this example. We have a function f, It's given. And I want to find the directional derivative of f. So I want to find the derivative of f in the direction of the vector u at the point 2, 1, like this. So what is this number? Well, according to the rule, it's going to be fx at the point 2, 1 multiplied by u1 plus fy at 2, 1 multiplied by u2, like this. Here is the unit vector u. So what is u1 here? What is u1? U always in the form u1, u2. So we need 4 things. We need this, 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 and this. u1. What is u1 here? What is the number u1? Square root of 3 over 2. Good. Okay. Square root of 3 over 2. What is u2? Half. Thank you. Yes. All right. So we already have these two numbers. Good. Now I need to find fx, the derivative of the function with respect to x, first at any point xy. Okay. So let's look at the function. So it's going to be 2x, yeah, thank you, 2xy, which means that fx at 2, 1, so I'm really looking for 4 things. 1, 2, 3, and 4. So that means at 2, 1, it's going to be 2 times 2 times 1, so 4, so 4. Finally, I need also fy, the derivative with respect to y, at xy first, which is, yeah, x squared minus 12y squared. Huh? Thank you. Yeah. And therefore, fy at 2, 1. So we substitute x with 2 and y with 1. So what will that give us? Yeah. Minus 4. Okay, great. So let me just, yes. Okay. Is it not minus 4, huh? It's minus 8, yes? Minus 8. Okay, so we have now, yeah, minus 8. So now we can, yeah, now we can say that the directional derivative, now we can write, so the derivative of our function f in the direction of the vector u at the point 2, 1 is going to be 4 times u1, which is square root of 3 over 2, plus minus 8 times half, like this. And I think if you do this calculation, you will see that it's going to give you roughly minus 0.5, like that. Are we okay with this? Now, I want to do part B. Part B, I want the derivative of the function in the direction from 2, 1, from the point 2, 1 to the point 4, 0. So part B, let me, yeah, part B. Now, so from 2, 1 to the point 4, 0. Okay, so here, what do we need to find first? Let me go back to the rule. Remember, when you want to use the rule, you need the partial derivatives, fx and fy, and you also need the unit vector u1, u2. So these are the four things you need to find the directional derivative. So first, find the vector v. What is the vector v from this point to this point? 2, yeah, 2 minus 1. Okay, this is the vector v. Then we need to find, so first you need that. Then you need to find the unit vector now, u. You need the unit vector u in the direction of v. Unit vector will be 1 over, what is the magnitude of v? So magnitude of v multiplied by v. Yeah, so it's going to be 1 over square root of 5 multiplied by 2 minus 1. So the unit vector u is 2 square root of 5 minus 1 over square root of 5. So that means u1 is 2 over square root of 5 and u2 is minus 1 over square root of 5. Okay. Now, what do we need to do after this? So what do we need to do? Remember the formula, the rule? You need four things, yes? You need four things to actually calculate, to find the directional derivative, du. You need u1 and u2. You also need, yes, you need fx, yes. You need the fx. Yep. So we need the fx, which we already have, yes? I think we already have. So these times we don't need to calculate them again. They're already there. 4 and minus 8. Yeah, because it's the same point, 2, 1. So fx is 4, fy is minus 8. fx at 2, 1 is 4, and fy, yeah, fy is minus 8. Okay, that means now, so the directional derivative of f in the direction of the v or u, it's the same thing, yeah, at the point 2, 1, this time will be 4 times 2 over square root of 5, and then plus minus 8 times minus 1 over square root of 5. And we can do the calculation with take your calculator and find this. Can you do it, please? And give us the answer. Yeah. I think it's the same point, yes? Yeah, good question there, Salha, yes. The question is, find the derivative of f at the point 2, 1 for both a and b. Yeah, for both a and b, the point is 2, 1, so there is no problem. So we will need fx at 2, 1, and also fy at 2, 1. So it's exactly the same number. Does that make sense? What is different is the vector. What is different is the u1 and u2 are different because we are taking a different direction now. We are going in a different direction. So u1 and u2 will be different, but because we are at the same point, fx and fy will be the same. But good question there, yes. I think the answer is 16 square root of 5 over 5, something like this. Yeah, which is 7.15, I think, is it? Yeah, roughly, if I remember well, maybe 7.15. Yeah, something like that. Okay, so that is the idea of the directional derivative. It's really quite simple to calculate it, and you will see questions like this. So very important rule here for calculating, yeah, important rule for calculating the derivative of a function in a certain direction of a unit vector u. Okay. Now, okay, here is another example. We have a function f of x squared plus y squared this time, and I want to find the derivative of this function in the direction of the unit vector u, where u is in this direction, is in the direction of the vector v. So v is -3, 4. And I want to find df in the direction of u at the point 1, -1. Okay, so many things we need to do here. What is the first thing? So this is a really important question, girls. You will see this, believe me, in your final, in test number 2. This is a really important question. You need to know how to do this. Now, what is the first step? So we have a function defined in R2, and I'm looking at, okay, I'm looking at the point 1, -1, which is here, 1, -1. At that point, I want the direction of the function in the direction of the vector v -3. So x is -3, y is 4. So it's kind of going in this direction like this. This is the vector v. So I want to know what is happening to our function in this direction of the vector v. Is it increasing, decreasing? So what is the value of its derivative? Okay, what is the first step then, girls? What is it? Come on, let's get some help. fx, yeah, why not? We can start with fx, why not? Let's start with fx. What is the derivative of f with respect to 2x, yes? But I need this fx at which point? At which point? Yeah, 1 -1. Yeah, I need it at 1 -1. 1 -1. So substitute, you will get 2, sir? 2. Yeah. What is the second thing? Fy, yeah? I need Fy now. Fy is 2y. So the value at 1 minus 1 will be minus 2. Good. Now, what else? What else do we need? The unit vector. Very good. Yes. Okay. So we need the unit vector. So I need the unit vector u will be, as always, the rule is 1 over the magnitude of v multiplied by v. So what is the magnitude of v here? 5. Okay, great. Minus 3, 4. So we will get the vector minus 3, 5, 4, 5. Okay. That means U1 is, what is U1? Minus 3 over 5. Yeah? Minus 3 over 5. And U2 is 4 over 5. Now we are ready. Yeah? Hence, we are ready now to write the derivative of our function in the direction of u at the point 1 minus 1. خلاص. We can do it. Yes? So what is it? 2 times 2 times what? Not 4 over 5, huh? Minus 3 over 5. Good. Plus, yeah, minus 2, great, times 4 over 5. Excellent. And that's it. And this calculation, yeah, will give us what? 14 over 5, I think, yes? Not for minus. Huh? Is it minus? Minus, yes. Minus 14 over 5. Okay, great. Okay, good. So this is the derivative. So what can you say then in the direction of this vector v? What's happening to the function as the point xy moves in the direction of the vector v? What can you say about the function? It's decreasing. Very good. Yes, it's actually decreasing because its derivative is a negative number. So as we move in the direction of v, the values of the function will be decreasing. That's basically what this is telling us. Okay, great. Yes. Now, are we okay with this? The directional derivative, the way we calculate it? You can, there is part B there, which is similar. Yeah, part B, you try it. Yeah. So B, I will leave it to you to try as an exercise. See what happens. Okay, now, okay, I think, let me go back a little bit. Yeah, now we can define the gradient of a function. Basically, the gradient is a vector, yeah, which is made up of the partial derivatives. Yeah, df over dx and df over dy. That vector is called the gradient of the function. Okay, so let me just consider an example here. If I say here is a function, let's say 3x minus y squared, and I want to find the gradient of the function at the point xy. So you need to find the partial derivative df over dx. So this is called the gradient. df over dx here will be, what is df over dx for our function here? 3, yeah? 3. And df over dy is minus 2y. So that means the gradient of our function f at any point xy is going to be 3, the vector 3 minus 2y. So that is the gradient of the function. It's a vector. Now, this gradient, of course, I can find it, for example, I can find it at the point, at any point, yeah? For example, if I want it at the point minus 1, 5, then at the point minus 1, 5, the gradient will be 3 minus 10. That's it. Yeah, that's the vector gradient. So the function has a gradient at every point. The gradient at 0, 0 will be, so what will be the gradient of this function at 0, 0? 3, 0. Yeah, exactly. 3, 0, etc. So we get different vectors. At every point, you get a vector which is called the gradient of the function. So function of two variables, it's like this. With three variables, yeah, it's exactly the same thing. If I consider a function of three variables, for example, f, x, y, z is the function xy. Let me consider like this, xy, yz, and x squared, let's say, like this. What is the gradient of the function? So it's going to be df over dx, yeah, and then it's the vector df over dx, df over dy, and df over dz, like this. So what will be, in this case, the gradient? What is df over dx for this function? Y plus 2x, good, yeah. So that is the first component. Df over dy will be, yeah, x plus z, excellent, yeah. And df over dz will just be y, excellent, okay. So again, if I want this gradient at a particular point, I can find it. For example, at minus 1, 2, 3, then I can find it by substitution. Yeah. So if I put x equal minus 1, y is 2, so that will be 0, I think. Yeah, it will be 0. And then x plus z will be the 2, and y is 2. So this is the gradient of this function at the point minus 1, 2, 3. So that is the gradient of a function of 3 variables. So it's just the vector formed by the partial derivatives. Okay. Now, okay, let me just, I don't want to do anything new now. I just want to check one or two examples here. Here is a function f. I want to find the gradient of this function. So gradient of the function f. So what will be, so the first, remember the gradient will be df over dx and then df over dy. Yeah, this is what the gradient is. So we want to see the derivative of this function. Sarha, yes, you already have the answer. Yeah, so it's going to be 2x df over dx plus 4y squared. Huh? Yes. So this is df over dx, and then df over dy is, yeah, that's fine. Thank you. Yeah. Aisha, yes. 8xy minus 5y to the power of 4. So this is the gradient of this function at any point xy. If I want it at a particular point, you just substitute, and that's it. Here is a function. I want its gradient at the point. So I want the gradient of this function at the point 2 minus 1. What is it? Okay. So we need the partials, derivatives. So let me just try. Yeah, find fx, fy, and then substitute. Exactly. That's all you need to do, Yani. So E4, except that here finding the partial derivatives may be a bit tricky. We need to, yes, we need to use the chain rule. So we need fx. Okay. So you need basically the derivative of this. What is the derivative of this with respect to x? So it will be 2 multiplied by the derivative of this thing here with respect to x. What do you think that derivative will be? 4 over y. Thank you. Yes. Thanks. No, yes. It's 4 over y. Exactly. E for x over y minus 2. That's it. Yeah. So you can find fx at 2 minus 1 by substitution. So if we substitute here, so it's going to be minus 8 e to the power of 4 times 2, 8, e minus 8, huh? Minus 2. So is that, yeah? Substitute x with 2, y with minus 1, and I think you will get that, yes? And then the second, of course, we need the fy. This time it's going to be 2, and the derivative of 4x over y with respect to y will be minus 4x. Yeah, thank you, Salah. Yes, minus 4x over y squared. Exactly. E 4x over y, and that's it. Yeah, there is no, the derivative of 2x is 0 with respect to y, so we get fy at 2 minus 1. So 4 times 16, minus 16 e to the power of minus 8. And therefore, the gradient of the function, I will write it up there. So the gradient will be the vector minus 8 e minus 8 minus 2, and then minus 16 e minus 8. I think this is, yeah, fx, fy. So that will be the gradient of this function. Okay, I think we will stop here today. It's a really heavy, 2 heavy sections, maybe not very simple, but I hope I made things at least a little bit clear. Any questions at all here? Anything you want to ask me, girls? Are you okay? All right. I'm sorry, but some of these sections are quite heavy, and I hope you will look back, go back, review it, read it again, or listen to the videos, and that may make things a bit better for you. Okay, so have a nice day, and I will see you next time.